Similar to the field effect transistor, there are three different useful modes associated with the BJT transistor. There's the cutoff mode, the active mode, and the saturation mode. Each of these modes are defined in terms of the state of the two PN junctions, the base to emitter junction and the base to the collector junction. The transistor is in the cutoff mode if the base emitter junction and the base collector junction are reverse biased. In other words, both of the PN junctions are reverse biased. This corresponds to a positive voltage from the collector to the base and a voltage from the base to the emitter less than the voltage necessary to forward bias that junction, or something less than 0.3, 0.2 volts, 0.4 volts, somewhere in there. Generally speaking, we'll talk about it being in this junction being reverse biased when the base voltage is approximately 0, or the base to emitter voltage is approximately 0. In the cutoff mode, there are no currents flowing through the transistor. The base current, the collector current, and the emitter current are all 0. The active mode of the transistor corresponds to the base emitter junction being forward biased and the base to collector junction being reverse biased. This is the case of this is the state of the transistor when it's operating in its linear region, and it's analogous to the saturation mode in a field effect transistor. It was this mode that we considered the operation when we gave the qualitative description of the BJT in the first video. And finally, there is what is known as the saturation region, where both the base emitter and the base collector PN junctions are forward biased. Don't confuse the saturation region in the BJT with the saturation region in the field effect transistor. In fact, as we've already pointed out, the active region in the BJT is similar to the field effect transistor's saturation region, and it's in this region that you have a linear relationship between the input and the output. The saturation region of the BJT corresponds to the triode region of the field effect transistor.